We completed Cartesian product. Next, we are moving to the next topic, relations. Let us consider two sets P and Q, where P is set of the three alphabets A, B, C, and Q the name of some children. That is Ali, Bhanu, Chandra, Bino, Divya. Now, if you write the Cartesian product P cross Q, it will contain 15 pairs, isn't it? See, n of p is 3, n of q means 5. So n of p cross q means 15 pairs will be there. Okay, that is A Ali, A Banu, A Chandra, A Binoy, A Divya. Same way B Ali, B Banu, B Chandra, B Binoy, B Divya. Same way C Ali, C Banu, C Chandra, C Binoy, C Divya. Okay, so n of p cross q contains 15 pairs. Okay, now I am going to define a set R such that set of all pair xy. R is the set of all pairs xy such that X is the first letter of the name Y. X is the first letter of the name Y. Name Y. Okay, where X belongs to P and Y belongs to Q. Now, which are the pairs come in this set? Let us take first letter A. A is equal to X, then Y should be a name starting with A. Then which you want? Ali. So A Ali. No other names are starting with A. So only one pair A Ali starting with A. Okay. Next B. X equal to B means the name Y should be a name starting with a B. So two chances are there, Banu and Bino. So you will get two pairs, B Bhanu and B Binoy. Next letter is C. There is only one name starting with the C, that is Chandra. So C Chandra. Okay, here we defined a relation from P to Q. What is that relation? That X is the first letter of the name Y. Okay, so this R is a set that is known as relation from P to Q. R is a relation defined from P to Q. Okay, now see the elements. How many elements in this relation? 4. Okay, now see what is P cross Q. It contains 15 elements and R is a subset of this P cross Q. R is a subset of the set P cross Q. So a relation is defined as, so R means a set that is a subset of the Cartesian product of two sets. That is, if A and B are two sets, R is a subset of A cross B, or R is equal to A cross B. Okay. Now, there are two ways to represent a relation. One is roster form, another one is set builder form. That is already we discussed. Okay. Now third one is a visual representation, that is arrow diagram. Arrow diagram. Okay. See, we use oval shape to mention the sets. In the example, we have taken P and Q, so we can write PQ, and we are going to define a relation from P to Q. That's why we will keep one arrow mark, and here you write R. See, that's why it is arrow diagram. Okay, now what are the elements in P? A, B, C. Elements in Q means the name of some students. Ali. We can change the name also. Bhanu. Then Binoy. Chandra and Divya. Okay. Now in this relation, A is related to Ali, so we will keep light arrow mark like this. B is related to Banu as well as Binoy, so we will draw like this arrows. Then C related to Chandra. So this is the representation of a relation using arrow diagram. Then clearly we can say that which are the elements related to each other. See, here A is related to Ali, B is related to two of the elements, Banu and Binoy, C is related to Chandra. Now in the second set, Divya has no relation with the first element in P. In this way we can analyze the relation. Let us discuss another example. Let A is equal to set 1, 2, 3, 4 and B is equal to set 3, 4, 5, 6. Okay. Now define a relation R from A to B such that R is equal to set of all xy such that y is equal to x plus 1, where x belongs to A, y belongs to B. Okay. Now we can draw the arrow diagram. Then easily we can understand. This is A, this is B, relation R from P, A to B. Okay, here elements 1, 2, 3, 4 and here 3, 4, 5, 6. Okay, now y is equal to x plus 1. Okay, now when x is equal to 1, what is y? 2, but 2 is not included in the set B. Next, x is equal to 2, y is equal to 3. So 2 is related to 3. Same way 3 is related to 4, 4 is related to 5. Okay. So in this way we can represent the relation. Okay. Now see the element in the set A. Here 1 has no relation with any of the element in B. Same way in the second set B, 6 has no relation with any element of the set A. Clear? Now the elements in A which are related, their collection means set 2, 3, 4. So set 2, 3, 4, the elements that have relation, that are known as, that set is known as domain. Domain of the relation. Here 1 is not included because 1 is not related to any element of B. Okay, now range means the set of all elements in second set B which has relation with the A, elements of A. So which are they? 3, 4, 5. So set 3, 4, 5. So domain means if you write the relation in roster form, the set of all first elements is known as domain, and the set of all second element, that is known as range. Okay, so that is first elements means elements of the first set, second elements means elements of the second set. Clear? Now the second set B is completely known as codomain. Codomain. Okay, this second set B is known as codomain of the relation. Now see this range and codomain. This range is always a subset of codomain. Sometimes that is equal to codomain. Okay, let us discuss one more example. Let A is equal to set 4, 9, 16, 25 and B is equal to set -2, -1, 0, 1, 2. Okay. Now define R is equal to set of all pairs xy such that x is the square of y. X is the square of y, where x belongs to A and y belongs to B. Let us draw the arrow diagram. -4, 9, 16, 25. -2, -1, 0, 1, 2. X is the square of y. So 4 is the square of -2 and 2. 9 is the square of 3, but 3 is not there. 16 is the square of 4. 16 also square 4 also not there. So only two pairs, that is 4, -2, 4, 2. Okay. So what is the domain? Domain means a set 4 and range set -2, 2. Clear? Now if we change the set to B, okay, if we include some more elements in set B, that is -4, -3, -2, okay, then 2, 3, 4. Let us include 5 also. 5, -5 also we can include. Okay, now let us draw the arrow diagram. Change in the set B. Okay, that is -5, -4, -3, -2, then 2, 3, 4, 5. Okay, Now x is the square of y. So 4 is the square of negative 2 and 2. Okay. 9 is the square of negative 3 and 3. 16 is the square of 4 and negative 4. 25 is the square of 5 and negative 5. Okay. Now see every element of X, first set A is related to every element of B. So what is the domain? See, domain is equal to set. See, 4 is related to an element in B, 9, 16, 25 all are related. So domain becomes 4, 9, 16, 25. Okay. Then range means a set of all elements in B. That is minus 4, minus 3, minus 2, 2, 3, 4, 5, then negative 5 also. Okay. Or we can say that domain means A, that set completely, and range is equal to set B completely. Okay. So range can be a subset of codomain. See, B is the codomain. So range can be subset or equal to codomain. Okay. Okay. So these are the points you have to remember: domain, range, and codomain. That is, domain means set of all first element in the relation, and range means set of all second element in the relation. Okay.